Welcome back. One more type of volcano to discuss, and that is the stuff of legends, the stuff of movies, the super volcano. So, a super volcano isn't necessarily massively big on the surface. It's actually kind of simmering below the surface. So when these kind of erupt, you get a lot of material getting pumped up, massive amounts of material getting pumped into the atmosphere, and then the land just kind of collapses. They're associated with rhyolitic magma in lava. Rhyolitic magma in lava, high silica content, very high viscosity, meaning very sticky stuff. It doesn't really want to move. It's just real sticky material, so you can get a lot of pressure building up from below. That's a lot of gas. And when they finally build up enough pressure to make their way out, largest eruptions, extensive ashfall, violent eruptions, thankfully, very rare. I mean, we're talking about eruptions that will change the world, that may block out the sun for days, months, weeks, for the whole world, months. So thankfully, they're rare. Some examples are in Yellowstone, right underneath Yellowstone National Park. Yellowstone is famous for all those geysers and hot water features. Guess where all that heat's coming from? Yep, here's a super volcano bubbling underneath Yellowstone, and the Valles Caldera. These are usually caused by hot spots underneath continental crust. So you get these hot spots melting this continental crust, which is typically granite in nature, which has a high silica content. Which you melt that, you're going to create rhyolitic magma or lava. High viscosity, high explosivity, high gas content. Yeah, they happen. So this isn't necessarily a great image, but it kind of gives you an idea of what happens. So typically underneath a supervolcano, you have a large magma chamber, and it's filled with, again, this very sticky rhyolitic magma. Very sticky, very slow moving, a lot of gas and pressure built up. So when they finally do erupt and all this material just starts getting pumped out of the magma chamber, well, you can imagine now there's nothing really there to support the land above. So then it just kind of just collapses in on itself. So a volcano that kind of collapses in on itself creates what's called a caldera. A caldera. So we see these in Yellowstone National Park. Again, those are just mountains in the background. That's not a volcano. The volcano is just kind of underneath. And so it might just kind of sit flat on the surface, and then it explodes, and then the leftover material kind of depresses in. Well, Yellowstone has actually erupted a number of times in the geologic past. So what you are seeing is kind of the depressed caldera around the ring of mountains that kind of form the outline of the material that didn't erupt. So yeah, Yellowstone, it's a pretty big one. There's documentaries, there's movies about this. So as far as eruption style, how a supervolcano erupts. Here's Mount St. Helens. This erupted in 1980. This is a stratovolcano. So this is the ash cloud at Mount St. Helens, which was a Plinian eruption. So a big eruption. So this is the ash cloud that was created, where the ash fell. And that was a large eruption. Well, so here's where Yellowstone is, on the northwest corner of Wyoming. When this erupted 640,000 years ago, this is the ash fall that we see in the geologic record. So we can look and dig in layers in the past, and this is how far the ash extends to. Much bigger than Mount St. Helens. So when these go, this is just ash fall. This doesn't even count the amount of ash that got pumped into the atmosphere and then just kind of dwindled around. This was the initial just ash fall. So it's massive. There is also an extinct supervolcano in California, the Long Valley caldera that erupted 700,000 years ago. Also a large ashfall area. Another active supervolcano is just right next door, right in New Mexico, the Valles caldera complex. So you can see from I can see it. I don't know if you can, but right immediately my eyeball picks out this kind of circular nature depression. My eyeball just kind of just went right to that. So that is the collapsed caldera from where this last erupted. So you can see this is just north of Albuquerque, maybe about 100 miles or so. So here's kind of an image if you were to fly over it. So this is the caldera itself. You have little resurgent volcanic peaks in the middle, but overall it's not like a big mountain-shaped volcano. It's more of a relatively flat feature, and then when it erupts, it kind of crumbles in on itself. Excuse me. So here is the geologic evolution of the Valles caldera. So looking from about, I'm going to say 44 million years ago to 1.4 million years ago. Starting to get early volcanic eruptions of lava and ash. But from 1.4 to 1.1 million years ago, you get a larger magma chamber buildup and a caldera collapse and resulting ash flow and eruption. And then, so 1.1 million years to present, the caldera floor is kind of being bulged up as the magma chamber is resurging. So it erupted, about 1.1 to 1.4 million years ago, caused that collapsed caldera, but now it's resurgent and kind of pushing things back up. That's fun to think about, isn't it? 325. You got me? 325. One more time. 325. Part of the code. You'll need that. So let's go ahead and stop here. Let's talk about, when we come back, the hazards associated with volcanoes. I've touched on some. We'll talk about them a little bit more in depth. Most people, when they think volcanoes, they think lava. That's not really the thing we should be worried about. One, most volcanoes don't emit lava. Two, it's probably the gentlest of all the hazards. It's all the other stuff we got to worry about. And that's what we'll talk about when we come back.